Mechanical wave is a wave that is an oscillation of matter and therefore transfer energy through a medium. While waves can move for a long distance, the moment of the medium of transmission, the material, is limited. Therefore, the oscillation material does not move far from the initial equilibrium position. Mechanical waves transport energy. This energy propagates in the same direction as the wave. Any kind of wave that it can be mechanical or electromagnetic has a certain energy. Mechanical waves can be produced only in a media which possess electricity and inertia. Also that we can have this tension. A mechanical wave requires an initial energy input. On this initial energy is added, the wave travels through the medium until all its energy is transferred. One important property of mechanical waves is that their amplitudes are measured in an unusual way, displacement divided by the wavelength. When this gets comparable to unity, significant non-linear effects such as harmonic generation may occur, and if large enough, may result in chaotic effects. So we have transverse wave and longitudinal wave. Here in these pictures we can see the difference about these two waves. The longitudinal wave is like a string only, and with this transverse is waves cause the medium to vibrate at a right angle to the direction of the wave or energy being carried by the medium. Meanwhile, in the longitudinal wave, we don't have a medium exactly. We only have like 1%. Well, the medium is only pushing like a string. Moving on with the experimental part, we made it with wooden sticks, gummies, and tape. Later, we're gonna show you our first fail, and we figured out that the mass here is very important because we made it the previous one with clay, and different clay balls are with different mass, so the weight doesn't seem good. So here is the correct one. So now in the data part, we are gonna get the different results. So we are starting with the length. We have to identify that we have the length of our project, that is the gummies with the tape, and we're gonna have lambda. Lambda is the wavelength. So to get this data, we're gonna use the next formula, that is L, it's equal to the one I told you before, that it's the distance, that it's the gummies with the tape, the length of that. And so L, it's equal to lambda over 2. This is equal to well, we're gonna remember that our L is 1 meter, so lambda is equal to 2L. Lambda it will be 2 meters. So that represents this part of the wave. Then we are gonna get the constant k. The constant k is equal to the wave number. So k is equal to 2p over lambda. K is equal to p because 2p over 2, it will be p. So now we have k that is equal to pi, and we're gonna get the angular velocity that is equal to 2 pi over the period. We know that the period, it is the measure of time it takes for the wave cycle to complete. We usually measure the wave period in seconds, and we represent in the capital T. Now, so this is gonna be the cycle of our wave. This one, it's the representation of the period. And we get this, and it's 1.5 seconds. So now we're gonna get the angular velocity, that it's 2 pi over 1 seconds, and it's equal to 418 radians over a second. Now we're gonna get the frequency. The frequency is equal to 1 over the period, and that it will be, this will be 0.66 hertz. So now we're gonna get the velocity of propagation, that we have to remember that it's different for the angular velocity, and the velocity of propagation is v equal of frequency per the lambda, and the result is 1.332 meters per second. Now we're gonna identify what we have at this moment, that it's lambda is equal to 2 meters, the angular velocity 4.18 radius per second, and the velocity of propagation. Now we're gonna have the tension. The tension is with the next formula, that is velocity squared multiplied by the density, and the density, we're gonna get the linear density, that it's equal to the mass over the volume, over the distance. So we get the mass of our gummies, the gummy sticks, it's 109 kilograms over 1 meter, that is the length of those gummies with the tape. And we have the linear density is 0.19 kilograms over a meter. So we have the tension, we have the density now, so we can continue for getting the tension, that it will be 0.337 newtons. We have it in newtons because, as we know, the tension is a force. But now we're gonna miss the amplitude, so we're gonna watch the next video to know how we get the amplitude. Here we have the amplitude in the equilibrium position. So we get with this technology, we use high technology to have this. It's the amplitude is 0.45 meters, and we can prove with the plus and the less amplitude, so it's like actually the same. So now we can get the transversal velocity, and this will be, well, the formula will be the next one. This will be that when the time is 0 and the position also is 0. So the formula will be velocity is equal to minus omega multiplied by the amplitude. So this will give us a negative number, but it's only indicating that we start like from above, and it's 0.18 meters per second, but the velocity of propagation, it is positive only because of the function we have in the with the negative sign, because it's the derivative of the position. So then we also have the calculus of the acceleration, and the maximum acceleration it's with the formula that it's equal to minus omega squared multiplied the amplitude, and we get also it have the negative sign, but we don't count it like negative, and it's only indicating like the direction. When the it's up, the acceleration it's like down, and vice versa. So the acceleration it will be 0.7862 meters per second square. The speed of propagation is proportional to the tension and is inversely proportional to the density. So our test of wooden sticks didn't work at all, because the sticks with clay didn't have the density of the, like our string with the gummies. It was higher, so that the propagation wasn't achieved in an adequate way. So when having low tension, the speed will be smaller, and if the density is smaller, the speed will be higher, because as we said before, the speed of propagation is proportional to the tension and inversely proportional to the density.
Sí, ya se pierde en medio.
So now we have the calculus for the low tension. This will get with the next formula as we used it before, that we get the period that it was 1.9, sorry, it was 3.8, and the frequency was 1 over 3.8, that is 0.266 hertz. So with that we can get the velocity of propagation with the formula, so it will give us 0.57 meters per second. Then we have the medium tension, that we get it like the same way with the same formula, but here we have like the period, it's 2.4 seconds, and the frequency will be 0.466 hertz, and then the velocity will give us 0.83 meters per second. So we can have some conclusions that with the tension it is like it affects in a proportional way to the velocity of propagation. Basically, the recommendations was like to be very careful with the mass and with the tension, because as we see like all the relation these two have with the velocity of propagation,